All right, this section 4.7, we are talking about completing the square. So our essential question, how do we solve quadratics using square roots, and how do perfect squares help us to solve quadratics? So we have an example here, x squared plus 20x plus 100. I'm looking at the first term, x squared. I'm looking at the last term, 100, and I can see that these are perfect squares. So the special squares pattern was ax squared, and then plus 2ab, and then plus b squared. Is equal to ax plus b squared. So let's check. Square root of x squared equals x. The square root of 100 equals 10. So if we take the ax times 10 and double it, we should get our middle term, and we do. So we can write this as x plus 10 squared equals 81. And we already learned that from here we can take the square root and then subtract 10 to get x all by itself. And then because these are integers, we can just solve for both values of x. Negative 10 plus 9 equals negative 1. Negative 10 minus 9 equals negative 19. So these would be our two solutions. So this is an example where it worked out nicely to use square roots, but we don't always have that option for us, and sometimes we have to make this nice for ourselves. So how do we do that? We do what's called completing the square. Step 1, we want to identify the constants. Step 2, whatever b value we have, we want to divide it by 2. And then step 3, whatever quotient we get in step 2, you want to square it. And that is how we find the value of c. Sometimes we can just stop there, but other times we'll have to solve the equation. So we would add the value from step 3 to both sides of the equation if it were asking us to solve. This first example is just saying find the value of c, so we only need to worry about the first 3 steps. Step 1, identify the constants. A equals 1, b equals 8, c equals, I don't know. So let's go to step 2, divide b by 2. B over 2 same as 8 over 2, so that becomes 4. And then step 3, here's the quotient we got in step 2, 4 squared equals 16. So we can rewrite this equation as a difference of squares. Or I'm sorry, not a difference of squares, as a perfect square binomial. But for now, we can just solve for c. C equals 16. If we did want to write it and go on to step 4, we would say that x plus this step or this value we got in step 2 and then squared. So this question, we will apply the rest of those steps, or that last step I should say, but we still want to identify what is a, what is b, and what is c. A equals 1, b equals negative 10, and then c equals 1. There's step 1, done. Step 2, divide b by 2. We get a value of -5. So then for step 3, we want to figure out what this value from step 2 squared is, and that's 25. So now we can add 25 to both sides of the equation, and I would put it directly behind the bx term. So x squared minus 10x, bring this value down, plus 25. Don't forget we had this plus 1 in the beginning. Add it here, and then equals 0, but because we added 25 to the left, we also have to add 25 to the right. And now we have set up an equation so that we can solve this. So don't do anything with the left-hand side just yet. I would say simplify the right side. And then take the first 3 terms, x squared minus 10x plus 25. Write this as a perfect square trinomial. So we're going to do x, and then because the value we got in step 2 was -5, we're going to write x minus 5, and then squared. And now, this is a question we've seen before. We want to get the x minus 5 squared by itself, so subtract the 1. Take the square root of both sides. 24 is not a perfect square, so we can factor. And look for the biggest perfect square we can find. For us, that's 4. So we should get positive or negative. Square root of 4 is 2, and then 2 square root 6. Then add 5 to both sides. And then because this one's irrational, we can just write x equals 5 plus or minus 2 times square root of 6. How do we handle this when we do not have just 1 in front of the x squared? If you can, factor. Factor out any greatest common factor that you can. So I see 2x squared plus 20x plus 14 equals 0. All of these are even numbers, so we can factor out a 2. And then you can divide both sides by 2 so that it goes away, and then you don't really have to worry about it. And now we can do the rest of those steps. Figure out what A, B, and C equal. Take B divided by 2. I'll do that off to the right-hand side. Square this new value from step 2. And add that to both sides of the equation. And again, put the 25 directly behind the 10x. Simplify for sure the right-hand side, and if you want, you can rewrite the x squared plus 10x plus 25 as a perfect square binomial. And that's just x in parentheses with a square. And then inside of parentheses, use this value from step 2, the plus 5. Oops, and I did not leave enough room for plus 7, so I'll put that up front. Now we can subtract 7 from both sides. So we have x plus 5 squared equals 18. Take the square root of both sides. 18 is not a perfect square, so we have to factor it and find a perfect square factor. Look for the biggest one we can find, which on this list is 9. So use the pair 2 and 9. And then subtract both, or 5 from both sides. Okay. One more example to go over. We want to change this quadratic function we were given so that we can rewrite it in vertex form. It's gonna be the same concept where we have to do the b squared and then square that value. This is just gonna help us write it a little bit differently. So let's do that first. Step 1, just like what we've seen before. What are your constants? A equals 1, b equals 18, and c equals 95. So right now this isn't a perfect square, but let's go to step 2. B divided by 2 is going to equal 9. And then for step 3, we want to take this value of 9 and then square it. And if this equaled 0, yes, we would absolutely add 81 to both sides and then rewrite it as a perfect square. But for us, we don't have to do that. We have the number 95 for our c value. So we want to rewrite this as a sum of two numbers. And we want those two numbers to add up to equal 95. So we're going to rewrite 95 as 81 and 14. So y equals x squared plus 18x plus 81 plus 14. And then we're going to write perfect square binomial with 9, the value from step 2, inside of parentheses, and then add 14 to the end. All right, that's all for today for completing the square. Good luck and let us know if you have any questions.